Okay, so if you've done one of these problems before, to make these be roots, that means we need 3 and 2 minus 3i to be zeros for the function. A root is something you can plug in that makes it equal 0. So for that first root of 3, I'm going to put an x minus 3 piece in my polynomial. That way, if you plug a 3 into it, 3 minus 3 gives us 0. So for the second root, I'm going to do something similar. I'm going to do x, that way I have a place to plug it in. And if I'm plugging in a 2 minus 3i, I'm going to say minus 2 plus 3i. That way, when you plug in these numbers, you plug in a positive 2, it gets canceled out with my negative 2. When you plug in that negative 3i, it gets canceled out with my positive 3i. So this parentheses makes that a root. But then we have to go back to the instructions here, because if you multiply this all out right now, you're going to have imaginary coefficients. I is going to get tangled up in everything. So to make sure imaginary coefficients happen, you have to add in an extra 0 here. The complement, 2 plus 3i. Sorry, the conjugate is the right word for that. The conjugate to this imaginary number. 2 plus 3i is the conjugate because the imaginary coefficient has an opposite sign. So I'm going to add in extra parentheses. This is going to be a root they didn't tell me to have explicitly, but I need to have it in order to have real coefficients. Some magic's going to happen, and we're going to have all the i's cancel out just because of this green piece that I just added. Okay, so just that's a tricky point there. Real coefficients, you need to have the conjugate be a 0 as well, or else you have imaginary coefficients. Okay, so let's put this in standard form, and in order to make that happen, you can multiply this times this first, but it's going to take you forever that way. Multiply this times this. Because of the conjugate piece, it's going to make a bunch of terms cancel and make your life easier. So the first one, x times x, gives us x squared. We got x times negative 2 gives us negative 2x. We've got x times negative 3i, that makes negative 3ix. For this next one, negative 2 times x gives us negative 2x. Oh, it's going to be a lot. Negative 2 times negative 2 gives us positive 4. And then we got negative 2 times negative 3i makes a positive 6i. Just so I don't lose track of everything, let's do the last one right below. We got 3i times x. That makes positive 3ix. We got 3i times negative 2. That makes positive 6ix. And they got 3i times negative 3i. That makes negative 9i squared. And every time you see I squared, you should think, oh boy. Well, nobody probably says oh boy when they're talking about math, but you should think, I know I can simplify this. I squared is negative 1. This is negative 9 times negative 1 is going to give us positive 9. But let's go through and do some simplification. There's nothing to simplify with x squared. We got a negative 2x subtracted by a 2x. That makes negative 4x. No other ones to combine there. So negative 4x. You got negative 3ix plus 3ix. Those are going to cancel right out, just like we said they would, because it's an imaginary number, a complex number times its conjugate. It's going to make all the i's go away. So let's see what else we got. Ooh. I dropped an x right here. Sorry, if you follow this gold trail. No, I didn't. No, there's not supposed to be an x there. I added an x right here. This isn't 3ix. If you follow the blue trail, 3i times negative 2. I messed that up, shoot. That should be a negative 6i. 3i times negative 2 gives us negative 6i. And the reason why I was able to catch myself there is because I knew that if I multiply a root that has 2 plus 3i times a root that has 2 minus 3i, conjugates of each other, all my i's should cancel. So I was able to catch myself because of that fact. So those all canceled out beautifully. Now we just have that positive 9 that we saw plus 4. That makes positive 13. Okay, so all we've done so far is we multiplied that black times that green parentheses. So what we still have left over is we still have an x minus 3. So go through your multiplying polynomial arithmetic. You're going to multiply x times everything in this parentheses. but I'll skip over that step. Write the final answer here. And then when you combine like terms for your final answer, when you combine like terms for your final answer here, x to the third has nothing to simplify with. These guys make negative 7x squared. These guys make 25x. And then we got minus 39 at the end. Okay, so that's the standard form of the polynomial once we multiplied everything out. And it has those roots because we start off with the factored form of the polynomial.